we need to prove this formula by mathematical induction. R equals 1 to n of r cubed. Or I should say the sum from r equal 1 to n of r cubed is equal to n cubed over 4 times n plus 1 squared. I'm going to ask you to pause the video and go ahead and solve it. Okay, good. Have you finished? I mean, not to solve, but to prove. I should say to prove it. So, here, we're going to look at the steps in dealing with it. The first step, we're going to show that P1 is true. So, when P1 is true, R is 1, so is 1 cubed is equal to, n is also 1, so is 1 squared over 4 times 1 plus 1 squared gives you 1 squared over 4, that's a quarter, times 1 and 1, 2, 2, 2 is 4, a quarter by 4 is 1, and 1 cube is 1, right? You don't need to prove that P2 is true. But suppose you do that. You want to show that P2 is true. What it would be is 1 cube plus 2 cube, all right, is equal to, so R changes. R is 1, then it is 2. But n is just the number that you count up to. So you're adding from R equal 1 to n. So wherever you stop counting up to, that's n. R is 1, then it's 2, then it's 3, then it's 4, and so on and so forth. But wherever you stop counting, if you stop at 15, then n will be 15, alright? So in this case, n is 2, so you have 2 squared over 4, 2 plus 1 squared, here 2 cube is 8, 1 cube is 1, 8 plus 1 is 9, so the right hand side should be 9. 2 squared is 4, 4 over 4 is 1, times 2 and 1, 3, 3, 3 is 9, so 1, 9 is 9. So you see that? Left hand side and the right hand side are the same. Right? If you want to show that P3 is true, here you have 1 cube plus 2 cube plus 3 cube. This is 1 plus 8 plus 3, 3 is 9, 9, 3 is 27. 27 and 8, 27, 28, and 9, 30, 22, 33, 35, and 1, 36. So on the left hand side you have 36. Well, you stop counting at R equal 3. R was 1, then 2, then 3. So n is 3. So here is 3 squared over 4 times 3 plus 1 squared. 3, 3 is 9 over 4 times 3 and 1 is 4, 4, 4 is 16. 4 into 4, 1, 4 into 16, 4, 9, 4 is 36. So 36 equals 36. See that? Okay. Now that is going to be the reason why when we change from R equal 1 to n to R equal 1 to k, we change the n as k. But we do not change the R. R remains R. Because R is not a fixed number. R keeps changing. 1, then 2, then 3, then 4, then 5, and so on. Alright? Okay, anyway. We had looked at step 1 already, which you must show when you're solving it, right, in exam, test, class test, assignment, homework assignment, whatever the case is, you must show that P1 is true. The next thing that you must show is this. Well, you're going to assume, if you write, you're going to assume PK is true. If you write prove here, you lose marks. You are not proving something, you're assuming that PK is true. So going from R equal 1 to K of R cube, you don't change R, it's just R cube equal. Remember, you change N to K. So it's K squared over 4, K plus 1 squared. Alright? Now, that's the next step, step 2. The next thing is, you must show that it is also true for the term after K. So, let's erase this. And you're going to show you're going to prove that PK plus 1 is true. So what you're going to do is change N to K plus 1. Alright, so you're summing up from R equal 1 to K plus 1. Sum from R equal 1 to K plus 1 of R cube is equal to, now this is K plus 1 over 4, in bracket you have K plus 1 squared. Alright, now as is the case when it comes to proving by mathematical induction, which involves a summation, you're going to split the summation in two parts. You're going to split it into sum from R equal 1 to K of R cube, right, plus the K plus 1, the next term, K plus 1 term, and that is equal to K plus 1 over 4 times, well, this would turn out to be K plus 2, because it's K plus 1 squared. Alright. So, here, R equal 1 to K of R cube. We're going to, we can't simplify and show the left hand side and the right hand side equal with this summation sign here. So we're going to change it to this form. This is R equal 1 to N, and over here is N squared over 4, N plus 1 squared. So when you go R equal 1 to K, it should be K squared over 4, K plus 1 squared. So this now change to K squared over 4, K plus 1 squared. You see that? In this form. It goes from N squared over 4 times N plus 1 squared to K squared over 4 times K plus 1 squared. Alright. Plus, now what is the K plus 1 term? What is it? Well, in the first term, we have the first term 1 cubed, second term R cubed, third term, in the first term 1 cubed, second term 2 cubed, third term 3 cubed, fourth term 4 cubed, kth term K cubed. So the K plus 1 term, K plus 1 cubed. This is going to be K plus 1 cubed. So it is K plus 1 cubed is equal to K plus 1 k plus 2 squared over 4. Alright? Now, look at this. We're going to use our knowledge of fractions. Now, in the previous videos, we used the thing there, the common denominator method. But we could use the LCM method as well. Let's do that here. Remember, k squared times k plus 1 squared over 4. Everything is over 4. So let's put this over 4. And this line, well, this line is lean. So let's get rid of this line and draw a straighter line. And this is over 1. Suppose you're accustomed to using the LCM method. Use the LCM. LCM of 4 and 1 is 4. You say 4 into 4 goes 1 time. 1 times this will be it itself, k squared, k plus 1 squared plus 1 into 4 goes 4 times. 4 times all of this is going to be 4 k plus 1 cube. Alright? Equals. Now it would be the same thing as saying top times 4 times bottom by 4. And then everything will be over the 4. This and this 4 is this, right? It's going to be the k squared plus k plus 1 square, that plus 4k plus 1 cube over 4, alright? So it would be all of that. Same thing. Yeah. Alright, so here now, let us see how we can change up the left hand side to look like the right hand side. The fact is, we could just multiply out all the brackets on the left and multiply out all the brackets on the right. And we see we have the same thing, right? But the more sophisticated way is to change one side to make it look like the other side. So let's change up the left hand side, see if we can make it look like the right hand side. Up top here, we have k plus 1 squared, k plus 1 cube. Let's factor this out now. K plus 1 squared and k plus 1 cube. Let's factor it out. Factorize k plus 1 squared, the common factor. Inside the bracket now we have k squared plus 4k plus 1. Alright, this is all over 4. So you see that? So that's equal to what you have on the right. Let's look at this. Let's open this bracket, right? We're going to have k plus 1 squared. Let's use round brackets now. K squared plus 4 times k is 4k plus 4 times 1 is 4. All over 4. Now, here, we could factorize this, because I can see it can be factorized. If you say we're going to factorizing k squared plus 4k plus 4. What do we have now? AC method. A is 1, B is 4, C is 4. 1 times 4 equals 4. Two numbers that multiply to give 4 and to give 4 are 2 and 2. So we have k squared plus 2k plus 2k plus 4. Remember, you must remember your factorization of quadratic expressions, right? So group them and factorize again. K outside the bracket, k plus 2 plus 2 outside the bracket here, k plus 2. Remember that? This is going to be, you factor out k plus 2 now. It's going to be k plus 2, and inside the bracket you have k plus 2. K plus 2, which is k plus 2 squared. So you rewrite this now. You're going to have k plus 1 squared is k plus 1 squared times this part here, we saw a while ago that it is k plus 2 squared. So it is k plus 2 squared divided by, and it is all over 4 is equal to, what did we have on the right hand side again? K plus 1, have k plus 1, k plus 2 squared over 4. We have, hold on, we have a k plus 1 square on the left and a k plus 1 on the right. Let me see what happened here. We have k plus 1 squared. K squared, we take out k plus 1 squared here. And this is what we have. On the right hand side, we had n squared. Oh, my mistake. This n became k plus 1. So n squared became k plus 1 squared. I realize that mistake. This would have been k plus 1 squared. Alright? So I realize that happened. It should be k plus 1 squared times k plus 2 squared. So it's k plus 1 squared times k plus 2 squared over 4. Alright? So we have the left and the right hand side being the same. Alright? So sometimes it's easy to make mistakes like this. Right? If I was marking it and I see that you wrote, when you change your n to k plus 1, you did it here, so you would know that you should have k plus 1 and then square, and here you had your k plus 1 term, which is k plus 1 cube. I would recognize that you want to change your n to k plus 1, and that's what you did correctly. Then you change this and you write k plus 1 without the square. I would assume that maybe under exam pressure or so, you just happen to forget the square, but you know what you're doing. So I wouldn't necessarily take off marks for that. But once you reach the end here, and you see that there should be a square here, I would expect that you check back and realize that you had left the square off here, like what I did. Alright? But anyway, what I want you to do, if you did not prove it before, write down the question, close the video, and make an attempt at it on your own and prove it. Okay, so that's it for now. I'll see you in the next video.